The next example is collateralized debt obligations. This is the famous financial instrument that led up to or contributed to the major collapse in 2007. And one of the reasons that is attributed to the debacle is that the CDOs did not take into account the interrelationships between the input variables. Let's look at what this is about, and then the issue will make more sense. Okay, CDOs are asset-backed securities with a number of underlying assets. So each asset, the underlying asset, okay, um, are divided into different tranches having different risk characteristics. So the individual tranches are then sold as a single investment. So each tranche will consist of a variety of assets, and each of those assets that make up the tranche will have different risk characteristics. Now, when you put all of them together, the idea is the pluses and the negatives will try to balance each other. So the overall mix, the overall tranche uh, would be less risky. So that's the idea. Okay. Now we're going to look at two different tranches. Okay. One we call junior and the other senior. Junior tranches, okay, default when even one of the underlying assets, yeah, or just a few within a threshold default. So if that happens, then the entire tranche is declared as defaulted. The senior tranche, on the other hand, is only declared default when all the underlying assets go default. Then the tranche is default. So by combining risky assets, the senior tranches may be far less risky than the individual underlying tranches, underlying assets. Okay, but one of the major assumptions that, or at least whether explicitly made or implied, was that the default characteristic or default outcome of the underlying assets are all independent. Those assets are independent. The performance of one asset is not going to in any way be similar to another asset in the same tranche, and that is the Achilles heel that caught them. Senior tranches earned top rating for low risk, even though the underlying assets were quite risky. So before the 2007 crisis, mortgage risks were thought to be geographically uncorrelated. Okay, so what happens in city A or region A, it has no impact or no relation to what happens in region B or city B. So if default become imminent in region A or region city A, okay, it's not going to affect what happens in a different city across the country in a different place. Okay, that is a problem. So the default rates of one region were largely independent of default rates in another region, which turned out to be incorrect because in some instances these are regional, but when you're talking about a particular threshold, when a particular threshold is reached, then these economic effects affect the entire country. So if one region is going down the tubes, then it spooks the people everywhere else, and then it starts to go down elsewhere as well. So, so what we're going to do is we're going to divide the assets into two tranches. Okay, so we're going to look at a simplified example. So there are only two assets. So we market the two junior tranche consists of these two assets. In which case, junior tranche will default if either one of them defaults, and then the same two assets sold as senior. The same two assets sold as senior tranche, which will default if only both of the underlying assets default. So first we will run the simulation as though the two assets are independent, right? So then, if that is the case, and we simulate the proportion of time the two tranches will default, and then match that against the fixed rating stable, and then see what kind of rating they will receive. Okay. And then we will introduce interrelationship between the two assets underlying the tranches. Okay, and we use what is called coupler. In this example, we're going to just apply coupler, and then in the next lesson, we'll start talking about what it is and try to understand what that means. Okay, so we will consider two cases. In one case, the assets are independent. The second case, we will use a coupler, and as I said, you can think of it as nonlinear correlation, and we will look at this nonlinear correlation anywhere between 0 to 1, and then as the correlation increases, what happens to the default rate of the two tranches, the junior and the senior tranche. And we will then map that against the Fitch rating and see what kind of rating they'll get. So then we will compare the kind of ratings these CDOs will get if the interdependencies is ignored and the assets are treated as independent, and then compare that against the case where we do take into account the interrelationship between the underlying assets.